What are the advantages of full wave rectifier compared to half wave rectifier? First advantage is ripple voltage is halved. Earlier the peak to peak ripple variation was large in half wave rectifier, and the peak to peak ripple voltage variation is nearly halved in full wave rectifier. PIV requirement is reduced to half. PIV is the peak inverse voltage. PIV is the maximum reverse bias voltage that the diode is subjected to in the circuit when the diode is reverse biased. PIV is 2 times of peak voltage of the input signal, that is 2 Vm for half wave rectifier, and only 1 time of the peak voltage, that is Vm for full wave rectifier, because in full wave rectifier during any half cycle 2 diodes are on at a time, and these 2 diodes would be in series at that time. So that 2 Vm is divided in between 2 diodes in series, resulting in Vm of PIV of Vm only across each diode. Full wave rectifier flips the negative half cycle of the input, else this is wasted. Flips the negative half cycle of the input and present at the output, improving efficiency. So you can see the diagrams of circuit diagrams and waveforms of input and output over a half wave rectifier and a bridge full wave rectifier. This is a half wave rectifier, load resistor, smoothing capacitor. Output is equal to Vp minus Vd on, and the ripple time period is Tin, equal to input time period. So this is the ripple. So if you consider the same values of capacitor and load resistor RL, and so the discharging rate will be same, the slope will be same when compared to half wave rectifier and full wave rectifier. But what is happening is, in half wave rectifier this discharging at this C into RL rate occurs for T in seconds, whereas in full wave rectifier this discharging at the same rate, C1 into RL discharging rate, occurs only for T in by 2 seconds. After half of the time again the diodes will be on because of the other pair of diodes will be on because of the negative half cycle, and again the charging takes place. So the slope or the roll down slope or the discharging rate is same because C1 and RL values are same in both cases, but the time available for discharging is less in full wave rectifier, that is half when compared to the half wave rectifier. So the peak to peak ripple amplitude also becomes half. Furthermore, PIV is also reduced because only one diode is there. 2 Vm appears across D1 diode only whenever it is reverse biased, but here D2 and D1 will be on at a time, or D3 and D4 will be on at a time, and hence the 2 series diodes will be sharing the 2 Vm of PIV. So each diode will have a PIV of only Vm effectively.